Hi, hello, this is Giri, teaching 10th Mathematics, the chapter Coordinate Geometry. Here are the solutions of exercise 7.1 and this is part 1 video. In this video, we will learn the solutions of question number 1, question number 2 and question number 3 of exercise 7.1. Dear students, here is the question number 1. Find the distance between the following pairs of points. I shall repeat. Find the distance between the following pairs of points. The first bit, the point 23, comma 0.41, and second bit minus 5, 7 and the point minus 1, 3, and the fourth bit the point AB and the point minus A minus B. Here is the solution for the given question. Here we have to find the distance between the following pairs. Let us observe the first bit now. In the first bit we have given 2 points. The first point is 2, 3, and let us assume that the coordinates of 2, 3 are x1, y1, and the second point is 4, 1. Let us assume that the 4, 1 is the second point whose coordinates are x2, y2, and we have the formula to find the distance between the points x1, y1 and x2, y2, which is given by root over x2 minus x1 whole square plus y2 minus y1 whole square. This is root over, let us substitute x1, y1 and x2, y2 values. x1, y1 are the values are the coordinates of the first point. x2, y2 are the coordinates of the second point. Therefore, this is equal to x2 value, x2 is equal to 4. Therefore, this is 4 minus x1 value is 2. 4 minus 2 whole square plus y2 minus y1. y2 is 1 and y1 is 3. Therefore, y2 minus y1 means 1 minus 3. 1 minus 3 whole square. Now, let us simplify this. Root over. What is 4 minus 2? Good. 4 minus 2 is 2. 2 square. Plus what is 1 minus 3? 1 minus 3 is minus 2 whole square. 2 square is 4 and minus 2 whole square means minus 2 into minus 2, which is also plus 4. Therefore, root over 4 plus 4 plus 4 is root 8, and let us write this root 8 as the product of 4 into 2. 4 2's are 8. Therefore, this is root over 4 into 2. That is root 4 into root 2. Root 4 value is 2 and this is root 2. Therefore, the distance between the points 2, 3 and the point 4, 1 is equal to 2 root 2 units. Similarly, let us solve the second bit now. In the second bit, we have given the point minus 5, 7 as x1, y1 and the second point minus 1, 3 as x2, y2. From this, x1 value is minus 5, y1 value is 7, x2 value is minus 1 and y2 value is 3. Let us use the same formula again. Distance is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. And let us substitute the values. x2 minus x1. x2 is minus 1 and x1 is minus 5. x2 means minus 1 minus x1. Here x1 is equal to minus 5, but we need minus x1 means let us change the sign of x1. Since it is minus 5, let us write plus 5. Therefore, x2 minus x1 whole square is minus 1 plus 5 whole square plus y2 minus y1 whole square. y2 is 3 and y1 is 7. y2 minus y1 means 3 minus 7. 3 minus 7 whole square. Minus 1 plus 5. These two numbers have different signs. This has minus sign and it has plus sign. In such a case, subtract the least number from the greatest number. That is, subtract 1 from 5. What is 5 minus 1? 5 minus 1 is 4. And the greatest number has positive sign. Therefore, its value is plus 4. Plus 4 whole square. Plus, in this case, plus 3 and minus 7. Again, different signs. Subtract the least number 3 from 7. Then 7 minus 3 is equal to 4. And this greatest number 7 has a negative sign, therefore this is minus 4 whole square. Plus 4 square is 4 into 4, 16. Minus 4 whole square is minus 4 into minus 4 is also plus 16. Now what is 16 plus 16 is 32, root over 32. You can write 32 as 16 into 2 because 16 is a perfect square number. Therefore, square root of 16 is 4 and square root of 2 is square root 2. And the final distance between these 2 points is 4 root 2 units. Now let us solve the fourth bit. Here the fourth bit is the first point is AB and the second point is minus A minus B. Let us assume the coordinates of the first point as x1 y1 and the coordinates of the second point is x2 y2. Now the distance formula is again the same formula you can apply, and x2 minus x1 whole square. X2 is minus A and x1 is also, x1 is plus A. Ready? 1, 2, 3. x2 is minus A and x1 is plus A. Let us substitute x2 minus A minus x1 means minus A minus A whole square plus y2 minus y1. y2 is minus b and y1 is plus b. Therefore, y2 minus y1 means minus b minus b whole square. Minus a, these two have same signs, minus and minus. Then add them and keep the same sign. Means minus a which is equal to minus 2a whole square. Minus b is minus 2b whole square. Minus whole square is plus 2 square is 4a square. 2 square is 4 and a square is a square. Plus minus whole square, minus into minus is plus 2 square is 4b square. This is equal to, let us take 4 common. 4 into a square plus b square. Root over 4 is 2 into root over a square plus b square units. Is it clear now? Good. Now let us solve question number 2 of exercise 7.1. Here is the question number 2. Find the distance between the following pairs of points 0, 0 and 36, 15. I shall repeat. Find the distance between the following pairs of points. The first point is 0, 0 and the second point is 36, 15. Now let us find the distance between these 2 points. The distance between the 2 points is nothing but the length of the line segment joining the 2 points. Please keep in mind. Yes. Now here is the solution. We are given 2 points. The first point is 0, 0. Let us consider this as x1, y1. And the second point is 36, 15. And let us consider this as x2, y2. And the distance formula, root over x2 minus x1 whole square plus y2 minus y1 whole square. x2 is 36 minus x1 is 0. 36 minus 0 whole square plus y2 minus y1 whole square means 15 minus 0 whole square. 36 minus 0 whole square is 36 square and 15 minus 0 whole square is 15 square. 36 whole square means 36 into 36, 1296 plus 15 square, 15 15s, 225. If we add these two, you will get root over 1521 and the square root of 1521 is 39. Wherever you find distance, you may write units. Good. Therefore, the distance between the points 0, 0 and 36, 15 is equal to 39 units. Good. Now let us solve question number 3. Here is question number 3. Verify that the points 1, 5, 2, 3 and minus 2, minus 1 are collinear or not. I shall repeat. Verify that the points 1, 5, 2, 3, minus 2, minus 1 are collinear or not. Now, first of all, let us learn what is meant by collinear. Collinear points means the points that lie on the same straight line. If 3 or more than 3 points lie on the same straight line, then ready, 1, 2, 3. Then they are said to be collinear points. Is it clear? If 3 or more than 3 points lie on the same straight line, then they are said to be collinear points. Now we have to verify that the given 3 points are collinear or not. Now let us check. Here is the solution. How to solve this question? You can solve this question in 4 to 5 different ways. and let us proceed using the area of the triangle formula. Here the given points are 1, 5. You can name them as x1, y1. The second point is 2, 3, x2, y2, and third point coordinates -2, -1, which is equal to x3 and y3. And let us write the formula to find the area of the triangle. Area of the triangle is equal to half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. And let us substitute the values now. x1 means 1 and y1 is 5. x2 is 2 and y2 is 3. x3 is -2 and y3 is -1. Let us substitute these values in the given formula. Area of the triangle is equal to half modulus x1. x1 is 1 into y2 minus y3. y2 is 3 minus y3 means let us change the sign of this. Therefore, it is plus 1. 3 plus 1. 1 into 3 plus 1 plus x2. x2 is 2. Okay, x2 is 2 within brackets y3 minus y1. y3 value is -1 minus y1. Change the sign of 5. -1 minus 5 plus x3. What is x3 value? Just observe. Yes, x3 is equal to -2 into y1 minus y2. y1 is 5 minus y2 is -3. Now let us simplify this. This is half modulus 1 into what is 3 plus 1? 3 plus 1 is 4. 1 into 4 plus 2 into -1 minus 5 is -6. -2 into 5 minus 3 is 2. Half modulus. You can read this as modulus. Half modulus 1 into 4 plus 2 into -6 minus 2 into 2. This is equal to half modulus 1 into 4 is 4 plus into minus 2 6 are 12 minus into plus is -2 2s are 4 and plus 4 and -4 may be cancelled and we have half modulus -12. Since it is modulus, modulus means you should consider only the positive value. Therefore, half modulus of -12 means half of 12. This 2 in 12 6 times. Therefore, area of the triangle is equal to 6 square units. Here, we found the area of the triangle which is not equal to 0. If the area of the triangle is 0, then you can say that the points are collinear, because if 3 points lie on the same straight line, then no triangle may be formed. If the triangle is formed means then there may be some area. If the triangle is not formed, then the area of the triangle if you find, you will get 0. If the triangle formed means there may be some area. Here, as you get area of the triangle is not equal to 0, so the given points are not collinear. Okay, good. We will solve some more questions in the next video.